Welcome to another episode of MathemaTING. I am Ting and I will be your host for today. Our topic for today is Descartes' rule of signs. But before we dive in, let us first set some objectives that you have to accomplish by the end of this video. First, know the significance of Descartes' rule of signs. Second, be able to determine the possible number of positive, negative, and imaginary roots a polynomial could have. Lastly, be able to apply and integrate the Descartes' rule of signs in understanding and solving algebraic problems. So, what are we waiting for? Let's now move on to the lesson proper. Basically, the Descartes' rule of signs provides an insight on how many positive and negative real roots a polynomial could have. It also shows the number of imaginary roots. For example, let p of x be equal to x raised to 5 plus 2x raised to 4 minus 11x cubed minus 8x squared plus 20x plus 16. The first step is to create a table with 4 columns and at least 1 row. The first column is for the positive real roots, the second column is for the negative real roots, and the third column is for the imaginary roots, and the fourth column is for the total number of roots. The total is determined by the highest degree of the polynomial because this indicates the total number of zeros. Let us now analyze the polynomial function. Look at the variations of the signs between the terms. As you can see, there are 2 variations between the signs. So therefore, there are 2 positive real roots. Let us now move on to the negative real roots. To get the negative real roots, you have to substitute x with negative x. Then, take note of the variations again. After simplifying, you can see that there are 1, 2, and 3 variations. Write this in the corresponding column. For the imaginary roots, simply get the total of the positive and negative roots and subtract it from the total. In this case, 2 plus 3 equals to 5, so 5 minus 5 means there are 0 imaginary roots. To get more combinations, simply subtract 2 or any multiple of 2 from either the positive or negative columns. Note that if there's only 1 or 0 on the box, you cannot subtract anymore as the number can't be negative. After subtracting 2 or any multiple of 2, add that amount to the imaginary column. Simply make sure that the number of positive, negative, and imaginary roots is equal to that of the total.
As you can see, the total number of positive, negative, and imaginary roots in all the rows is always equal to the total, which is 5.
Now that you know how to use Descartes' rule of signs, let us start with an easy problem. The question is, determine the number of positive real zeros of p of x equals 3x raised to 5 plus 5x squared minus 7x plus 6.
Now, count the variations of the signs between the terms. In this case, there are 2 variations. Again, construct the table. Then, write 2 on the corresponding column. No need to solve for the number of negative or imaginary roots, since the question is only asking for the number of positive roots. However, as we discussed earlier, remember to subtract 2 or any multiple of 2 if it's possible. Therefore, you can subtract 2 from the amount in the first row, and you will end up with 0. Write this in the second row. Therefore, the answer is, there are 2 or 0 positive real zeros. Great job! Now, let's move on to the average round. First, let's look at the variations. As you can see, there are none. So, construct the table and write 0 on the corresponding column. Now, we substitute x with negative x and we simplify. Then, look at the variations once more. You can see that there are 1, 2, and 3 variations. Write this in the negative column. Since the degree of the polynomial is 3, write this on the column for the total number of roots. To get the imaginary roots, add the positive and negative values, which are 0 and 3, and subtract that from 3. Therefore, there are 0 imaginary roots. Now, we can subtract 2 or any multiple of 2 from either the positive or negative columns. In this case, we can subtract 2 from 3. We will end up with 1. Then, the 2 that we subtracted will go to the imaginary column. These are the possible combinations. You're done! Good job! Finally, let's move on to the difficult portion. The given is f of x is equal to 2x cubed minus 7x squared minus 46x minus 21. F of x is the same as p of x, so don't mind the difference. Determine the number of positive and negative real zeros and the imaginary zeros. Write your answers in the table and verify by solving for the zeros of the function. Again, we first look at the variations of the signs. In this, we can see that there is only one variation. Construct the table and write 1 on the corresponding column. Next, substitute x with negative x and simplify. Now, we can see that there are 2 variations. Write this in the negative column. Again, look at the degree of the polynomial. This is the total number of roots. Since the degree is 3, we can determine that there are 0 imaginary roots because 1 plus 2 is already 3, meaning 3 minus 3 is 0. Then, we subtract 2 or any multiple of 2 if possible. In this case, we can subtract 2 from the negative column, leaving us with 0. Transfer the 2 to the imaginary column. Tada! You have another combination. How do we know if this is correct? Well, using rational root theorem and synthetic division, we were able to solve for the roots, which are negative 3, negative 1/2, and positive 7. We can see that this matches perfectly with our first combination, since it has 1 positive root and 2 negative roots. Congratulations! That concludes our problems for today. Let us now have a quick synthesis of the steps on how to use Descartes' rule of signs. That's it for today. Thank you so much for watching and learning with me. Once more, I am Ting, and this is MathemaTING! Thanks for watching! Don't forget to smash that like button and share. Sincerely, 10A Team 5.